We've got 2 different visualizers. Is this still on?
Yeah, we can hear you. Oh, we can hear you.
Yeah, I've got 2 mics on me. So.
That's cool.
All right. So one of them, like, how many of you have been in the build room and seen? All right, so you kind of know what we're talking about. So a guy who used to work there named Ryan Shelley is the one who wrote them. I've done a lot of hacking on them, but they're C and C++, so the source is available, but like if you want to make changes, it's going to be painful. It's on GitHub. I spent most of this week making some Debian packages. So first off, why did we do this? How many of you have like sifted through flows? It's horrible. There's nothing on the planet as boring as looking at flows or, you know, TCP dump output. Like, also, it lets us look at stuff in a different way, so we can, you know, like when you see things, it's a different part of your brain than when you're reading stuff off a page. They're really good for when management comes by and wants to take the tour. It's like, look here, we've done stuff. See, it's cool. We're cool. You still want us here. And I think the biggest thing is it makes people curious. Like you see this thing and you see this weird traffic. It's like, what is that? And people naturally, like, you know, our security guys will see something weird and they have to go look and see what it was, which helps us, you know, get better or more familiar with the traffic on our network. So the first one I'm going to show, he named it Organic IPs, or the Organic IP Visualizer, or something like that. We use libpcap to pull traffic off of an interface or out of a pcap file. And then we put the source and destination IP address up on the display and draw little blobs traveling back and forth between them. The IP addresses kind of push away from each other, and when there's stuff going between them, it kind of pulls them together so they kind of stay towards the middle of the screen. The server sends basically a summary every 24 seconds that has a huge list of source IP address, destination IP address, the protocol we saw, and how many bytes we saw. And the client uses that information to plot on the display. So let's go ahead and try a live demo. See if I'm cursed today. All right, so this is my laptop. I made it green. I'll tell it to stay in one spot so that we don't lose it. So we'll start off with just a normal ping. So there you can see ping. My laptop's talking to who knows what, just because that's what laptops do. We can, let's send a lot of traffic now. If I can type my password right. Looks like my wireless connection's not the greatest, but you can still see stuff going back and forth there. For our next demonstration, let's see what BitTorrent does. I had to go out of my way to find something that was well-seated but also legal. All right, so there we're starting up. We're still waiting for it there. We're starting to get a little data flowing. What's my wireless connection like? I think I may have caused myself to be throttled already. So you can see there's a lot of crap going on. And like, the average user, you talk to them about BitTorrents, like, BitTorrent's really bad on the network. Like, why? It's just copying files, right? When you're copying a file from, I don't know, 80 hosts, it can have an effect, right? All right, I'm bored of this. We'll see how long it takes for that to go away. All right, it's finally stopped. Well, mostly. It probably takes half an hour for everybody to forget who you were and stop talking to you. So let's go to a website. So everyone's familiar with CNN, right? Come on. Oh, I should probably connect to this other SSID. That would probably help. All right. What did I do? Whoa. Oh, this is broadcast traffic. I didn't do it. Someone else did it. We're okay. So maybe I should exclude that. So we'll add a PCAP filter, host, my IP. And reconnect here. All right, we're just looking at me now. Back to CNN, maybe. Still going, still going. I guess it's a really visual, quick way to give people an idea of what is it that you're talking to when you go to this internet thing, and how does it actually get there? All right, come on now. Thanks for that.
I just wanted to demonstrate it looks like that.
Yes, yes it does. Let's see, what else is there? So is there any requests? Is there any kind of traffic you're interested in trying to generate? So this is, the green stuff is still CNN.com talking back and forth. When I close my browser, there it closes all my connections. So any questions on this one? The bottom, the blue graph thing at the bottom. It's graphing bandwidth for the traffic that it's displaying. So
For all traffic display, not just for what's going in and out of your port.
it's for what's on the display. So everything that it draws, it calculates into that graph. So here's a massive ping to an undisclosed location. Well, it's obviously disclosed because it's right there. But so here we're pushing 4 megabits of ICMP, give or take. Any other questions on this one? IPv6, no. My usual answer is never, but I don't know. Go ahead.
Is it limited to what it can show, or would you put this at the border of the university, say,
So
see what was going on?
you could put this at the border of the university as long as you're very careful about what filter you give it. Obviously showing like 65,000 things on a little display like this is not going to turn out well.
Will it try?
It'll fail. It will try, but it will fail.
But it doesn't do any roll-ups, like deciders or anything like that?
What do you mean?
Say, I want to look at the track point that's specific stuff.
Yeah, so if you've got it on a port with visibility, you can give it an arbitrary PCAP filter, and it will only show you that traffic.
But you can't get it to summarize,
What do you mean? What do you mean by summarize?
like by /24.
No. It's designed for host-to-host communication. Right, anything else? What was that? Ryan Shelley, he had a CS class, they were doing OpenGL, he decided to do this as an assignment because he was working for IT at the time, and
I think you fall off I think you fell off.
it's possible. Yes, I did. Anyone else? Sorry, there's this big blinding light over there, so I can't really see. So just shout it out. Keep going.
Yep.
All right. The other visualizer is very creatively called IP Visualizer. Again, we're using libpcap. This time the server generates a summary where we look, so given a packet, we look for which IP address in that was to the network we're interested in. And we take the last 2 bytes of that and kind of put it in a list along with the protocol and a counter for the number of packets we've seen, and send that off to the client. The client makes this huge grid, or small grid, depending on how big of a network you're looking at. When a packet's received, it increases the color. As time goes on, the color fades. All right, so we got some videos here. So also in our installation, our border firewall is just a Linux box that I run. So we've had that, we wrote a program to send packet drop information to this as well. So all these white dots are packets that have been dropped by our border firewall. So this is Utah State University. This is our entire /16. You can see somebody's port scanning us over there. It kind of wrapped onto the next row. Each one of those boxes represents an actual network that's allocated on one of our routers. Each little tiny dot here, right. Each one of these little tiny green, red, or blue dots represents an IP address. So where this is a video, it doesn't show, but like 0.0 is in this bottom left corner here, all the way up to 255.255 up here, and it kind of tries to group them in blocks. We'll speed up the video because try a file name that actually exists. It helps. If you notice, I don't know if you can see it from back there, but it kind of looks like snow, like the old analog TVs, how you'd get this staticky look to stuff. Those are just random packets we're dropping from who knows where. Did you see the one right here? So there's all kinds of weird scanning going on.
So the white ones are packets you're dropping in the firewall?
Yeah, the white X's are packets we dropped at the border firewall. I think he was running Nmap against this little network right here when he recorded this. Also, this is four times the normal speed. So any questions so far? So now I'm going to go ahead. I've got a PCAP file of about a minute of our border traffic. We'll actually run this here. So this one's more recent than the other one, obviously. See, the networks have changed somewhat. Like here, this is our library. Here's DNS down here at the bottom. These are our public name servers right there. If you look at the top of the screen, it displays the IP address that you're pointing at. It's really hard to find anything with this low of a resolution, though. What was that? Sorry, I can't hear you.
Can you explain what each section represents?
The boxes? So the boxes are networks that are allocated. So this is the 0 network. That's a /25 where we put all of our DNS. My PCAP just ended.
Are those boxes defined by your config file, just so you guys know?
Yes, so where did I put it? All right. So I manually downloaded it. It's a nasty binary format, but you can do it. You just tell it, this is a network, this is a network. If you kind of see here how it's all kind of grayed out a little bit in this area, that's darknet. It's not allocated, allegedly. So for instance, this guy here is, that's the wrong one. Two, 3, 6, there we go. 6. So in an ideal world, there would be nothing coming here because there's nothing there. This is just null routed traffic that we're, did it end again? Yeah. And if you look, so each of these squares, it's actually 2 triangles. The bottom one is incoming traffic. The top one is outgoing traffic. So where this is darknet, if we saw something in the top, that would be something to be concerned about because we're sending traffic out from an IP address that's null routed. I don't know. Does any part of this look interesting to anyone?
This is not live.
Huh?
This is not live. Is this live?
No, this is not live. This is a PCAP file I took before I came here.
If you want to see a live one, go to Bill.
Okay.
Where is the host that actually collected that data?
Okay, so the host we actually get this data from, we've got a mirror port on our internal router that's connected to our border router that mirrors all of the traffic going towards the border. And from that, they send that traffic to NetOptics regenerative tap. So we've got the one mirror port that's getting regenerated to 8 mirror ports. We've got like 5 or 6 boxes hooked up doing different things, snort and that kind of thing. And this is one of those.
Well, if I wanted a smaller sample,
What do you mean by a smaller sample?
basically just one sample.
Oh, like a /24? You can do that. You saw, let's see, let's start this up one more time. You saw how I zoomed in here. If you can figure out where it goes as you're zooming in. So let's look at that one. That's a /24. And, red was UDP, green is TCP. There's not any blue on this one, but blue's anything else. Here, this is a bunch of our point-to-point links. So shortly after he wrote this, me being new there and not having a lot to do, right, I decided, hey, it's a 256 pixels by 256 pixels. What can we do with that? So in a minute here, we're going to get a port scan. I don't know. It's just kind of fun to sit and stare at. Not a lot of work gets done some days. So that was actually a port scan from across my border, yes. It's a display. Yeah. Yeah, so I wrote a program that'll take a 256 by 256 image and just put it up there. See, what time is it? All right, we got plenty of time. I guess there are any questions at this point?
Does the first OIP, does that also take a PCAP capture file?
Yeah, the other one can take a PCAP. It was acting a little quirky, so I didn't do that. See. I don't know, what other nasty traffic, what other nasty programs are there? Skype? Skype's a nasty one.
Skype's very nasty.
It just makes me sad to even open this up.
Hunter, shoot.
Just have to repeat it enough times to get the right length. I don't even remember my password because I don't use it. All right, here we go. Signing into Skype. That was weird. Did my IP address change? My IP address changed.
Yeah, you're off the usage. 192.168 is not used.
Dope. All right. Sorry. The joys of a live demo, right? All right. Try again. Oh, right. I remember why we had that filter.
38.13.
So that's the IP address when I ran the demo the first time. Now my IP address is 3.54. Oh. All right, I got a mouse here so that I wouldn't have this problem. I should use it. And it crashed. It does really well when you let it sit. When you make changes, it can get unhappy. So I'm just giving it a PCAP filter of IP host and my IP address. I hope. Apparently, closing the Skype window doesn't actually close Skype. I should have known that. Quit Skype. All right. That's what happens like when you connect to Skype. And that's what happens when somebody is here pinging me in the...
Not me. That might. Can you show BitTorrent?
Should do BitTorrent again. Oh yeah, try BitTorrent with the... I was having issues with the other one, right? Start again.
So is the red UDP traffic and the green
Yes.
TCP traffic again?
Correct. Red is UDP, green is TCP. Colors are not user configurable. Well, you could edit, there's a PNG somewhere you could edit. Oh, I think I killed it. Or should we pause that and try the Skype thing?
That works a lot better.
All right. Hey, look at that.
You're doing a great job.
All right, so an actual call, as expected, is just between two.
Are you calling, you're calling, is your phone on the inside net?
Yeah.
So it's on the inside. You see your from 172.19.15.101?
Oh, hey.
That's not me pinging. But yeah, it's
Who's, is that somebody in here?
not me. But yeah, it's routing straight from the inside.
I don't think it was much better.
Well, actually,
Can you turn off your Wi-Fi and then go back in? Not right now. If he does it, I'll. No,
what do you mean turn
I've
off?
been on the phone.
Oh, gotcha.
Oh, call from the outside? Yeah.
Good thing I have 2 gig of my data.
Just for time.
Yeah.
So,
Hey man, still doing a great job.
now it's routing 2 places at least.
Now I have no idea which is what. All right, who is this?
You didn't get it fast enough.
Oh, there. It looks like it's bouncing around, but it's.
Oh, there we go.
Ah,
Yeah, the back inside just went up.
All right.
But it's still doing unicast MP3.
Yeah, so it, I mean, it uses unicast, right? But
how many is that?
all right, I've had enough of that. So, what do you think? Do we want to do a field trip?
We've got 9 minutes till next speaker.
We can go for a field trip and look at the live data for the conference in there, or if you have other things you'd like me to display up here, we can.
Well, tell people what you've used it for.
So, at the security team likes it because they can go right on our border, watch for, say, TCP port 22 or 3389, and sit and watch and see who's managing machines from off campus, and you know, they go do a whois and all right, there's a connection from China on SSH. We should probably look at this more closely, that kind of thing. Mail servers, watching the mail servers at the border. You can find some interesting things on port 25. Go ahead.
What sort of amount of traffic, you know, you're saying dropping at the border, you know, our border is 10 gig.
Yeah, so our border is a 10 gig connection. We usually peak around 3 gigs during the day.
And the program can handle that?
So since we're using libpcap and we're giving it a filter, right, we're not showing everything because that would be difficult to process visually anyway. So we're giving it a filter, just say TCP port 22. There's not really that much TCP port 22 traffic. And libpcap's really efficient about ignoring the data that it doesn't need. Go ahead. Oh, so yeah, port 25, like if we watch port 25 at the border, they usually exclude our legitimate mail servers, which leaves the more interesting servers, things that you don't expect to be talking on port 25. So occasionally you'll see, a little bit of port 25. Some guest is there. They've got a mails relay that they connect to at their home place. But more often than not, stuff you see on port 25 is a compromised machine doing or sending out spam, right?
Is this client server model or?
Yes, client server, because we don't want to bring our data center traffic outside of the data center very bad. So there's a server that runs in the data center, a client that runs in our area there, I guess. So our 3 gigs or whatever of border traffic, we're throwing away enough that the other visualizer, I think the stream is like 10 megabits to keep that guy up during the peak of a day. So not too bad considering you're watching 3 gigabits worth of traffic.
The other visualizer,
Uh-huh.
can you control the time to live of the graphic display so watching the fade fast or slow?
Yes, you can. It's been so long since I've tried to do that. There's a keyboard shortcut somewhere. I don't remember what the letter was. Let's go try it out here. See, so I guess also we've got a bunch of different ways of displaying the subnets. So here it just kind of linearly goes 255 across the bottom and then up 1. So a /24 is an entire row. You see my my special port scan doesn't look like anything interesting here. What is this one? Oh, this is that weird. Anyway, I know half of you must read XKCD, right? The weird internet map they did with the. So he decided to make that as one of them. And what we found really quickly with this one, it is impossible to find anything. Like, let's check the time here. Oh, hey, there we go. Fade rate set to 5. It's the letter F. Can't tell, is that fading slower or faster? I think that's fading slower. No, I take it back. Whoever said faster was right. I was wrong. Any other questions?
Where do people get it?
Where do people get it? Ah, yes. It's on GitHub. Did I have a slide with that?
Yeah.
GitHub, here. You can find it here. I do have Debian packages for anyone who runs Debian. If you run a different operating system, you might be out of luck unless you want to port it yourself. It did run on Windows at one point in time, but that was a really long time ago. So I guess that's about all I have. Go ahead.
You said that there was, you were /16 or whatever. How many actual endpoints do you have? Like how many students and faculty are still?
Students, we've got, I think it's somewhere around 25,000 students. Faculty and staff, there are 3,000, I think. And, you know, everybody's got 2 or 3 devices anyway, so. We good? Sorry, what?
Is it possible to feed the client from multiple servers?
Not currently. I'd have to think about that. Submit a feature request. I may get bored, I may not.
Or submit patches?
Oh, send patches. I'm good with pull requests. Sorry, I can't hear. Oh. Then I shouldn't be able to hear. All right.